1, 2, 3, 4, 5, 6, 7, 8, 9. Start. Hello students, welcome to the current electricity quick revision 1. Yeah, I hope the voice is clear for everyone. Right guys, now let us discuss briefly few points in this session, especially what is electric current and few related points, and drift velocity, mobility, relation between electric current and a drift velocity, Ohm's law, electric resistance, okay, and electrical resistivity and conductivity. Some related points. Electrical energy and power. Electrical energy and power, and the remaining parts we will discuss in the next session. Let us see briefly with a few questions as well, along with few questions also. Right. First, what is electric current? See, electric current. Electric current is denoted by I, capital I or small I. So the rate of flow, what is electric current? The rate of flow of charge through a conductor, simplest form. The rate of flow of charge through a conductor is called electric current. More specifically speaking, so if you have a conductor like this is a cross-sectional area, and this is a conductor having length L and area A, right? And usually under room temperature and under thermal conditions, excuse me, yeah, under room temperature no current will be observed, because no, if you connect this to an external circuit or just any connecting wire also, nothing will be observed. Okay, but when it is connected to an external source of EMF called battery of EMF E or V volts, then it is observed that this establishes, okay, an electric field at the ends, and a force which drives the electrons which will move in this direction. And then that each electron is said to be carrying a charge of E. So the charge Q which crosses this area normally per unit time is called as electric current. More specifically, just in simplest form, you can define electric current as the rate of flow of electric charge. The rate of flow of electric charge through a conductor is called electric current. Is called electric current. Okay, it is denoted by I. Yes. How to give this mathematically is I is equal to the charge per unit time. You can also define it as a charge flown through a given cross section normally per unit time is called current. So rate means with respect to time. Okay, so Q by T, small q or capital Q also can use Q by T, whereas where Q is the total charge which is crossing the given area, the total charge which is crossing. If you observe this conductor, this area, any area or any intermediate area also per unit in unit time. So if one electron is crossing, the charge is E. If two electrons are crossing in a given interval of time, 2E will be the charge. If n number of electrons are crossing, then you have to take this charge as n into E by T, where n is number of electrons crossing. Whereas n is what? Where n is equal to number of charges. Number of charges, and E is equal to magnitude of charge of electron. E is equal to magnitude of charge of electron, which is taken as 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power minus 19 coulomb. So, and here we have to just remember few points, that how this current will be measured, means what are the units and dimensions of this electric current, and what is the nature of this electric current, whether it is a scalar or vector, and how to understand the direction of this current, conventional direction of current. Let us see these points briefly, quickly. The basic points of current are units and dimensions of current. Units and dimensions of electric current. Electric current. Electric current. Current is a general word, guys. Okay, current means a flow. So water current means flow of water. Okay, electric current means flow of electric charges. Wind current means flow of wind. So the current is a general word. Right. So units and dimensions of electric current. This current I, as because it is given by what is that charge by time, you can say SI unit of current. Unit of current in SI system, or SI unit of electric current. Electric current is because you see here Q by T, I is equal to Q by T, unit of charge by unit of time, that is coulomb per second. Coulomb per second, in short you can express it as C with symbols, coulomb per second. This has given a special name called ampere, we can say, and it is called ampere, and is also called ampere. Ampere, it is denoted by capital A within bracket, ampere A, which is denoted by A. Okay, and what about the dimensional formula of electric current? This is SI unit of electric current, guys. There is no smaller unit like, CGS unit. Okay, so in small values of currents can be expressed as a nanoampere, milliampere, microampere, like that, but no CGS unit. Now you can see how to write the dimensional formula of electric current. The dimensional formula, the dimensional, some noise background noise is there. The dimensional formula of electric current is. So while writing dimensional formula, we can write within the square bracket dimensional equation as I is equal to a dimensional symbol for current is A. So A power 1, we write A power 1 is the dimensional formula of current. Okay, dimensional formula of electric current is I is equal to A power 1 is a dimensional symbol. Or you can also write usually in terms of MLT, MLT, and along with this A, if you write, you have to write M power 0, L power 0, T power 0, and A power 1. This way also you can write the dimensional formula of electric current. But here another point, you can write it as a note. Note. The conventional direction of current always is taken as opposite to the direction of flow of negative charge and same as the direction of positive charge. This is very important while doing numericals. At this point you have to make use and you have to remember the conventional direction of current. The conventional direction of electric current is taken as number 1 opposite to the conventional direction of electric current is taken as opposite to the direction of flow of negative charges like electrons, whereas the conventional direction of electric current is taken as same as the direction of flow of positive charges. Okay, so if say for example here, if you see in the above example, or if this is a conductor, here if electron is flowing like this, moving from left to right, and if when it is connected to a battery like this, okay, because of higher potential, electrons are attracted towards this or drifted towards this. So electrons are moving this direction, means the opposite direction will be taken as electric current direction. Okay, whereas if protons are moving from left to right, then the same direction will be taken as the direction of electric current. Okay, right. So and here this electric current sometimes will be considered as what do you call average current and instantaneous current. Before that, whatever may be this, the current will be having a particular direction in a circuit. Let us say if it is a conductor is connected to a cell, then current will flow in this direction. This is the direction of current. When electrons are moving in this direction, the opposite direction will be taken as electric current direction. Right? A particular direction the current will have. So it is current will have some value, numerical value. It is equal to Q by T and some direction. So is it a vector? We have studied that any vector, any quantity, physical quantity having some both the magnitude and direction is called a vector. No, any physical quantity having both magnitude and direction and obeying vector laws of addition will be called as vector. Here, this even though having both magnitude and direction, it will not obey vector laws, so it is treated as a scalar. Electric current is treated as a scalar or scalar quantity as it does not obey, as it does not obey, vector does not obey vector laws of addition, as it does not obey vector laws of addition, as it does not obey vector laws of addition, even though having both magnitude and direction, magnitude and direction, right? So here we come across two mathematical representations. One is just for an idea purpose, just remember average current will be taken as will be given as A average is equal to delta Q by delta T. Delta Q by delta T. Whereas instantaneous current I instant is equal to dq by dt. Just in motion in straight line, average velocity, instantaneous velocity, right? Then same way you have to represent this. This is equal to, you can also say mathematically, limit delta q by delta t when delta t tends to 0. This is the mathematical expression for instantaneous current. Okay, all right. So okay guys, just this session we will continue afterwards. So what is, let us just briefly 30 seconds, let us recollect back what you have gone through in this 5 or 10 minutes. Then I will wind up, then we'll continue afterwards. Electric current. The rate of flow of electric charge through a conductor is called electric current, and it is given by I is equal to Q by T, which is equal to NE by T, where N is number of charges and E is magnitude of charge of electron. The value of it is given by 1.6 into 10 power minus 19 coulomb, and T is time. What is T, guys? T is equal to time in seconds. In SI units called seconds. Okay, and the SI unit of electric current, units and dimensions, you can see SI unit of electric current is given by coulomb per second, and is also called as ampere, and is denoted by A. The dimension formula of electric current is given by A power 1. Okay, and as a note, additional point, you have to keep it as a note or additional point. The conventional direction of electric current in a circuit or in a conductor is taken as opposite to the direction of flow of negative charges like electrons, and same as the direction of flow of positive charges like protons. Here you can write like protons. Alright, and electric current. What is the nature of electric current? Here I can say, even if you want some heading, you can mention this as nature. Nature means whether it is a scalar nature or vector nature. Nature of current. So as nature of I. Electric current is treated as a scalar as it does not obey vector laws of addition even though having both magnitude and direction. Sentence you can write in different ways. Electric current is treated as a scalar. Okay, and while doing the numericals, actually questions may come across based on these points also. Current can be classified into this kind of notations like average current and instantaneous current, and they are represented mathematically in this way, right? Some special cases also we may come across. Special cases. One such case we'll see now, then we'll continue later on. If an electron is revolving along the circumference of a circle, if an electron is revolving along the circumference, of a circle, then the equivalent current produced by it, then the equivalent means what? We'll see. Equivalent current produced by it means, if we consider a circular path or orbit, or he is moving in this path, circular path, as electron is a negative charge, the opposite direction will be taken as a current direction. Then equivalent current means during one time period, during a time of one time period. That is what you have to consider. So as a current, we know that current I is equal to Q by T. So Q is total charge. How many charges are there? One electron. So N into E, in terms of charge of electrons, N into E by time. Time equivalent means during one time period. So is equal to how many electrons are there? One electron. So the charge of electron is E by T is the equivalent current produced in this. Here, related to this, few more related points also can be asked to find. What is frequency? What is angular frequency? Like this kind of terms also, right? So, and related to this kind of application, if N1 electrons are flowing in a circular path, N1 electrons are flowing in the circular path in clockwise direction, and N2 protons are flowing in the same circular path in clockwise direction. N1 electrons flowing in anti-clockwise direction, N2 protons are flowing in anti-clockwise clockwise direction. Then the equivalent current is given by. So then we have to say, you have to take a number of charges. So when electrons are flowing in anti-clockwise, the opposite direction will give you the current direction. So N1 E plus N2 E gives you total charge. By the time period gives the total current. So this kind of points you have to just keep in mind. If you want to orally, I'm not writing this orally, I have given you this second application, right? You can copy it down. So we'll continue this afterwards. Now I'm winding this.